皆さんこんにちは。Hello everyone. 私は Danny です。My name is Danny. All right, that's all Japanese I know. Okay, so today today I'm going to talk about this topic. It's going GraphQL in line spots. Yeah. So this title is actually mixed with a lot of different keywords inside, like Go, GraphQL, and line spot. So I'll talk about each of them individually in the next few slides. Okay, so actually we're talking about implementing an API gateway for microservices. So we'll talk about a little bit about me and the API gateway and GraphQL, and also the state of GraphQL and Go. All right, so I'm a front-end engineer from Taiwan, and currently work for LineSpot, this project LineSpot. And what is LineSpot? LineSpot is a location-based service which you can quickly find like all the places, like interesting places, restaurants near you. So we have a landing page. You can just quickly look through the deals or coupons and things like that. And also there are like other pages, and user can leave like reviews, comments, things like that. And user can also rate on different restaurants. Okay, so that's about LineSpot. Now let's go to the point. So API gateway. Why do we need API gateways? So first, excuse the kind of messy sketch because I turned in the slides in the last minute, so I just hand drawn them. All right. So for now, let's say a client wants to connect to a microservice-based service. So this is like the traditional way to do it. Like the client connects to each service individually. So the clients will speak to A, B, C, and D, and aggregate all the data together and present it to the screen to the user. But sometimes this is not ideal because the network might be problematic, like especially on mobile. So the clients may be just grabbing service A, B's data fine, but lose data from service C. So the client cannot display the data correctly. So also, they might be service A might be talking in HTTP, service B might be talking in Thrift, and service C might be talking gRPC and something like that, and then that'll be problematic too. So what we're proposing is a service in front of all the microservices, and we call that service API gateway. So API gateway will do all the hard lifting, like it will talk to all the services and transforming the request and post processing the response back to the client, so the client don't have to do don't have to rearrange the data and things like that. So yeah, that's the main reason for API gateway. And also like since API gateway to all the services, they are just server to server calls, so they can talk to whatever protocols they want to do. Okay, so next, GraphQL. All right, so why do we choose GraphQL as a interface for our API gateway? And there are like 5 points. It's a data graph. So how do we define a data graph? A data graph is like you just model like all your data in your services into different types. Let's say for LineSpot, we have types like spots, location, and like reviews, comments, and things like that. So we just model the service as a data graph. And next, it's transfer agnostic. What does transfer agnostic means? It's just you can talk in whatever protocol transfer you want. So let's say you can use HTTP or WebSockets or whatever. Since GraphQL is just a query language, so it's what's passed inside the transfer that's important. Transfer itself is not that important. And then so the most common transfer we use is HTTP. So if you use HTTP for your GraphQL server, then you also have another added benefit, which is a single endpoint. Like if you use REST before, REST API usually have many endpoints to talk to different like resources. You can like modify, create, or whatever. But for GraphQL, it's just a single endpoint. And the next is type schema. So in GraphQL, which I'll show later on, each field is typed. So the developers or the consumers of your API don't need to ask you like, like what this field is or what that field is. It can just look at the schema, and also the documentation will be generated automatically. All right, so the last one is consumer centric. Also compared to the traditional APIs, GraphQL, the consumer can actually decide what kind of data to return. It can specify the fields and like all the queries and like the structure of the return data instead of like server just decided for you. All right. So let's take a look at an example. This is actually from GitHub API. So let's say I want to list all the issues from the Golang repository. And so this is using the REST API. So you can see I just do a GET request on the URL, and then it'll list all the issues in JSON format. And as you can see, it just lists out the data. And there are a lot of fields cannot fit into this screen, so I just remove them. There are a lot more fields than this. And let's take a look at GraphQL. So for GraphQL, the left-hand side is actually the query you send to the server. So you just tell it, I want repository, and then pass the server arguments to it. And then you just tell it, I just want the name and like the issues, and also the issue number and the title. And look at the right side. The server just return you exactly what you asked for. Yeah. So let's talk a little bit about Go. Like, why do you want to use Go to implement our GraphQL service? Like, when people talk about GraphQL, the first thing comes to mind is, oh, JavaScript, Node.js, things like that. So why do you want to use Go? Yeah, because why not? Yeah. All right. So let's just. So first of all, when we talk about development approaches, there are two different development approaches. The first one is code first. So code first is like you just use Go all the way down. You just implement resolvers and all the way down using Go, and then the schema is generated by the server. The second one is schema first. Schema first, you just define a schema using the GraphQL SDL, and then you pass that down to the server, and the server will parse the schema and then generate a server. So it's kind of the opposite ways. All right, so these are like the popular libraries for now, and the first one is code first. And the second one and third one, I'll talk about the second one, schema first, but we finally choose the third one because instead of just pass the server schema, this library actually generates all the it generates all the resolvers interface for you, so you don't have to write them by hand by yourself. So we chose this one. So let's go take a look. This is the GraphQL SDL. So let's say I have a simple service. It just returns posts. So each post will have an ID, title, and a body. So you can see all the types, all the fields are typed. So you can just, like a consumer can just look at this SDL and easily say, oh, you return posts, and posts have those kind of data. All right, so once you pass the SDL to GQLGen, which is the library we're talking about, it will generate this resolver interface for you. So it will automatically, since you define these two queries, so the resolver will have these two queries as a method. All right, as methods. So as you can see, the return data are also typed. So it also so you just implement the resolvers according to the interface. So you can just this is actually generated also from the library. And then the post type is also generated by the library too. So you can see that you just have 3 fields. All right, so so after you implement all the resolvers and things like that, you just create a struct, your resolver struct, and pass to the config, and then you just pass it back to the GraphQL handler provided by GQLGen, and then you can just use a regular Go HTTP server, and then it'll just run, and you just run your GraphQL server. So you can just create a server like that. Yeah. So that's all I got. Thank you.